Hey everyone, great to see you again at our AI office hours. Today we have a special guest, Emad. I'm super excited. I'll let Emad introduce himself uh, and we can also talk about what he's working on now. But also, there's some reasonably recent breaking news we can discuss, and then we'll go from there. Take it away.
Fantastic. Thank you for having me on, Illia, near team. Hi, I'm Emad Mostak. I was founder of Stability AI, best known for stable diffusion. But we also gave away 20 million supercompute hours in grants for the whole ecosystem with organizations like the Luther, Lion, and others. And ended up with 300 million open downloads. So hopefully, contributed to all of this going on. Now at Schelling AI, doing the decentralized version of that. Stability was meant to be a DAO of DAOs originally, but the technology wasn't quite there. But I think it is now, which is super exciting.
Awesome. Yeah, I'm excited to dive into kind of what like how Schelling approaches it, how people will be able to participate. But I just saw that Llama 3 400B was released, and so given you're a big proponent of open source and open weights, I'm curious to hear kind of your reaction and as well as just generally how you see kind of this evolution of open source space, um, given this comparatively large model now is available. uh, what can we expect?
Yeah, I think the numbers have just come out, and it looks like we have the first model that basically competes against GPT-4o and Claude Sonnet, which actually has been one of the best models I've used recently. It's definitely better than 95% of graduate programmers, I have to say that. Um, I think, there have been these charts of closed models going up like that, and then open models not quite catching up. But if you look at Llama 405B, the 405 billion parameter model, so it's like 800 gigabytes of weights, FP16, 16-bit precision, lower if you've got smaller precision. It was trained on 16,000 H100s for 3 months. That's like probably double, triple the compute of GPT-4 originally. And so Meta has 350,000 H100s, they got 35,000 now just for this. That you've just had Elon announce his 100,000 H100s for kind of Grok 3. And it's good that we have access to this technology because these models are like, graduates in a way. Like they go through high school, university, and then you can take them and tune them if they're open or if you have fine tuning capabilities, and then make them your own. And I think, Mistral, Llama, and these other models have created a really nice base from which we can go. But there is still, for now, the need to have these monstrous supercomputers again, some of the fastest in the world. To give an example of how fast it moves, we at Stability in summer of 2022 had a 4,000 A100 cluster. So that's the generation before this one. It was basically like 10th on the world's global list of supercomputers. This new Meta one with all the optimizations that have come through now is the equivalent of 64,000, not 4,000. And so again, it's been quite a leap up that we've seen in the compute requirements and more. And then the final thing I'd like to say as well is if you look at the Llama 3.1 like documentation, just had a quick skim before we came in, they basically incorporated many of the innovations from the open source ecosystem on model tuning, on merging together weights and more. Like looking at what the ecosystem is doing, that's something like what we did at Stability. Everyone built these fine tunes on top of the base stable diffusion model, and then we combined them together, and it learned from all these variants to create something closer to human preferences, which again I think is something very exciting when we start talking about decentralized distributed AI, how something can learn from our collective experience, but then be personal.
Yeah, that's a very good point. That I think as they had an opportunity to see what people are doing with Llama 3, they could actually bring it back and pick whatever was kind of interesting into this. I'm actually curious, yeah, because indeed this is a size and potentially quality, although obviously we yet to see this at practical use cases, right? Which is the actual test. But yeah, I'm curious, how do you see now competition of, like OpenAI is charging pretty hefty fee over how much it costs to run inference on just kind of base compute. And obviously, now everybody will start optimizing, like they already released, 8-bit, which is eventually fits on a single machine with a GPU. So you can have like a more, uh, like the cheaper inference pretty much in many cases. So I'm curious from an economical perspective, because on my side, I mean, that was always an interesting, like the point I made in beginning of 23 is like, I think open source will catch up. But it's even more is like open source is the way because you get all this improvements and inference, and then you're not limited by kind of your setup. And now you cannot incorporate those improvements yourself into if you have a closed source solution.
Yeah, I think that, when you were doing the groundbreaking research that led to all of this, you were doing research artifacts, right? And so you were scaling the compute on the attention all you need paper. You were then looking at these, and then we had GPT-3 and other things come out, but they were really research artifacts. They were not optimized. They weren't in the real environment with people trying out different ways to optimize it. With Stable Diffusion, we saw it go from 30 seconds an image to 300 images a second once the community got a hold of it. Like something like Stable Video, which is still probably the best open source video model out there, despite being released last year, was 40 gigabytes of VRAM the day we released it. Within a week, the community got it down to 8, which massively increased kind of the availability here. I think we saw something really fascinating last week when OpenAI released GPT-4o Mini, which was a 99% decrease in cost over the original ChatGPT model per token. 99%. We haven't really seen that anywhere. And if you kind of look at what's inferred, they've also taken some of the stuff from Open because, again, we haven't seen that much actually amazing originality from the open AIs and others of the world. Everyone in AI actually builds upon the shoulders of others. Because when you look at the actual code basis for running these models, it's like a few thousand lines of code at most. Like you replicate Google's Palm model, I think Lucid Rain's one of the most productive AI coders in open source. He did it in 200 lines of PyTorch, So it's not about that. It's more about understanding data. It's about understanding architecture and bringing all this together. But it does seem to be a bit of a race towards zero on cost. And what is the cost of doing a specific unit of intelligence? From writing a piece of code to doing these other things, the optimizations that are occurring now means that we've seen this competition occur really, really fast, especially because they're so well funded. And especially if you said you have this open source equivalent. So DeepSeek, actually, a Chinese lab, is the one that maybe kicked this all off. So DeepSeek was a hedge fund. They got 10,000 A100s and said, let's go and build models. And DeepSeek actually has some of the best AI models in the world that were the first to compete against GPT-4. They went from the average price was $15 for million tokens to 30 cents because they created this new MLA MOE architecture for DeepSeek V2. And then the whole Chinese market did that. Now the whole Western market's doing that. But with the open source stuff, you don't know how fast you'll get with things like Grok, taking it and adapting it. And you don't know how cheap you'll get with people, as you said, taking the quantization down. So when the weights come out and they're trained at 16-bit precision, you'll have 800 gigabytes for Llama 400B. But, even with 8 times 80 gigabytes, 640 gigabytes on a single H100 node of 8 chips, that's still too much. But when you quantize it down to 8 bits, then you get 400 gigabytes. Then you quantize it potentially down to 4 or 2, you have precision loss, it gets even cheaper. Where's that key benefit? We'll know because everyone in the world is going to now try it.
We'll try it.
How cheap it is. How can we engineer it?
Exactly. And people will now, okay, well, can we quantize and then fine tune for our problem so it's actually better?
Yeah. Can we take, one of the really interesting things now is that they changed their license on Llama. So you can use it for synthetic data creation and distillation as much as you want. So you can use the big giant model to teach a smaller model. You can distill down, and you can create synthetic data. So they use the big model to train and improve Llama 8B and 70B as well. And so now we can do that as well. We're the first commercially licensed model apart from DeepSeek that you can do that with, which again is super exciting. So I think it will just continue going down. I think we've got probably two more orders of magnitude through data optimization, model optimization, and chip speed up as we get the next generation chips coming over the next 2 years. So I think the cost is going to go from $15 per million tokens to 15 cents to 0.01 cents. And a million tokens is like what is it? Probably 700,000 words or something like that.
Yeah, it's like 2-3 books, like of sizable books.
Yeah, for 0.01 cents. Without even thinking about the edge stuff, that's insane, right? Like,
Yeah.
intelligence is too cheap to measure.
Yeah, I mean that would be exciting to see. I mean, even now on like 70B, right, you can get 70-80 cents per million tokens, which is already pretty cheap. And I think that for me the interesting always question was, right now we're unrolling obviously chain of thought, and so we're spending what output tokens are, like we're measuring kind of compute but with tokens. That's really what it is.
Yeah.
Which, it makes sense to actually measure compute, like how much compute it took, not how many tokens it spit out, and then being able to let model think without spitting out tokens constantly and using that more as a internal representation. But that's probably an interesting topic. There's actually a very interesting.
My piece.
No, those are a very interesting paper where they were doing kind of chain of thought unroll, kind of in latent space, on every token, and then teach it to see when should it do it or not, right? So like if it's easy for itself to predict the next token, it wouldn't do it, and if it's something hard, it would go drop into kind of latent space, do a chain of thought, which wouldn't come out as output token, and then use that to predict output token. And like I think some form of that machinery would be really interesting.
Yeah, I think that, it was interesting you said tokens versus compute, and then moving away from just these models guessing the next word to having more internal planning, basically mapping more parts of the brain. Because it's almost like type 2, like it's a type 1 thinking.
Exactly,
instinctive thinking is what we have right now. These models are instinctive animals, They're like not really reasoning. But if we can start unifying those together with agents, and I think this is where distributed ledger technology becomes so interesting, with kind of output formatting and other things, then you can actually have intelligence. Because one of the really fascinating things I think here is that Llama 400B is too big for consumer, right? But it's not as big as you can make it. You can make it 10 times as big, right? There's less people that can run it. A lot of these models are being optimized for the size of one node. Like Google, when they released their Gemma 27B model, said, well, it works on a single chip.
Mm-hmm.
But you think about intelligence. If I've got a piece of code that's very important that I want to write, then my compute or energy budget for that might be $10,000.
Yeah.
Not 0.1 cents. And so if the cost goes down another order of magnitude, even where it is now, at like 30 cents per million tokens or lower, then I could throw a lot of tokens, a lot of energy, a lot of compute at that. But how am I going to chain these models together? And this is where the mixture of expert stuff, where you have different experts for different things. Llama and I had a very interesting thing here. They had 1 million experts, and then they took the accuracy of RAG from 60% to 95%, the retrieval, which is great. You had Together AI kind of releasing their mixture of agents thing, where it routed to the appropriate best models and outperformed all the models there. You'll have this type of intelligent routing, intelligent agents with memory, solving complicated problems. And we've seen that with OpenDevin, Devin itself, and others, where once you take away the compute restriction from an energy output and the need for it to be like zero shots, just instinctive, you can do things that are just amazing. And this is just like, when I started my career as a software developer, I was writing assembler 23 years ago, right? We didn't have GitHub and all these things these kids today have. Now it's like blocks. We still got to build those building blocks. And that's, I think, amazing, exciting.
So maybe that's a good segue into Schelling, kind of how you see the world. I mean, you mentioned stability, right? Was originally kind of thought of as a DAO of DAOs. I don't know if you're comfortable talking about anything there, but would be interesting diving into kind of how Schelling sees the world and uh, how kind of you see engaging with research and kind of doing some of the things that didn't work in stability.
Yeah, so stability, we had these communities like Luther that we incubated and spun out and others. We had hundreds of thousands of developers, and we had things from like language models to image, video, everything. Because I was building a multimodal AI team, and I was like, from these communities, hiring, giving grants, we can get amazing people that are passionate to build great models. And that's what we did. The business side wasn't so good, but we still, broke a lot of records there, and we're heading towards profitability. But I was looking earlier this year at stability, and I was like, I built a multimodal AI team. I'm now going to have to go and raise $500 million to compete against these other guys. Like Cohere today just raised 500 million on 30 million in revenue. It was available, but then there was no sustainable model. And the reason we moved away from these like DAO's concept is that I was saying like, if we airdrop to the community, it's going to mess up the community. You're going to have a mixture of these researchers, conventional, non-conventional, and raccoons. It's going to get messed up. But the way this is all going, I saw that there was basically two gaps. Number one is every regulated industry, I believe, will require open data and open models because of the poisoning sleeper agent type stuff you get. So let's coordinate and build those for every nation, for every sector, all the cancer knowledge in the world available to everyone with a model that can outperform human doctors on diagnosis and empathy. That should be available. Open education model for all the kids. So we're starting with education, healthcare, we're making some announcements shortly. And also building models for each nation, one after the other. So we built a Japanese version of Stable Diffusion that reflects the local culture. We built Spanish models and Argentinian ones and kind of other things. Every nation needs self-sovereign AI. Every person needs self-sovereign AI, every community. So the idea of Schelling is basically to be the highest marginal dollar for compute, solving the demand side of DeepIn, and then use that directly and by giving it to research partners to build open infrastructure and research that the world needs. And so, Bitcoin uses 160 terawatt hours of energy. All of the data centers in the world use 350, which is insane. A lot of Bitcoin miners are moving towards AI compute now, but they don't know how to use it. We will use that all to build stuff that makes people's lives better. And then you can take these data sets, like we built Lion for images and Pile for language, and we released the Pile code, the code, Omniverse 3D XL, and models and layers, and you can just combine them, fully open source, to whatever you want to build the building blocks of these systems. So, multimodal AI team that's just building, and then having this store of value digital currency backed by a proof of work system, most likely. We're still ironing that out. That can then be used to fund the building of vital infrastructure for everyone. Not trying to do, the complicated stuff, keeping it simple. Long way to go, but, it started out well. And I think at the very least, the worst is that cancer, autism, dementia, Alzheimer's, all these conditions, we will have a fully open source, high quality data set and model that outperforms human doctors on empathy and diagnosis for all of them in the next 6 to 12 months. And that will make a difference to the world.
How do you evaluate empathy? What's the benchmark?
There are empathy kind of diagnosis ones whereby it's almost like an ELO score that they do on the cohorts. So Google had that with the output of MedPalm, and then others have done that like Stanford as well, these tests. The reality is human doctors have a low empathetic level because they're overworked, right? Because our current medical education system has to take everyone down to just numbers. That's why everyone gets the same paracetamol codeine prescription despite being individualized. Whereas the future that we want, you need to set user-owned self-sovereign AI. You can bring intelligence to the edge. How much knowledge do you really need for 90% of medical queries or educational queries? Enough to put on a MacBook, honestly, within a few years. And then you should be able to call to bigger models when you need to have a double check, right? I think that's the way that things will evolve. But as I noted, I believe that every regulated industry will need to have fully open data sets. And this is where Llama is fantastic, but it doesn't do enough. We don't know what the data inside it is. We don't know if it's in program to say that Mark Zuckerberg is awesome and Elon Musk kind of sucks.
Yeah, that was a joke conspiracy that I was to explain to people why open data matters is because we have no idea if it's like now subtly manipulating everyone.
But this will be important because, like, just like not your keys, not your crypto, it'll get to the point of not your models, not your mind. We will rely more and more on this technology. And so, again, from my perspective, all the regulated industries, education, healthcare, finance, will all require fully open models. So let's go and build those, right? And then you can call the open weight models for certain things and the closed source models for other things. Because closed source models will always outperform open ones. So you can always bring private data to them, and optimize it. But it doesn't mean that the base level has to be that different. Like, we had GPT-4 and then everything else. Now it's caught up. And there will always be a bit of differentiation, but they're good enough now for just about everything.
Yeah, and I think, I mean, the benefit is they cannot bring your private data to their closed source model, which you can do with open source model because you can run it yourself. And I think that's where the big quality differentiation, when we're talking about assistants, when we're talking about medical stuff, etc., because it just has all your information available
Yeah.
to understand.
And that's why I call it Schelling. I like Schelling point, the focal point in game theoretic terms like Bitcoin is. By deliberately creating amazing high quality national data sets, vectorial data sets, and models, it makes a lot of the work that you and others are doing a lot easier because you can have pre-installed models with really understandable standardized latent spaces. Like why Stable Diffusion 1.5 is still so widely used because the base model is so understandable that the fine-tuned things that we put on top are compatible, right? And so we want to have these graduates that have got to high school level where we all know what that is. But then they've gone to local university and they've gone to vocational school. And those are predictable. That makes a lower requirement for fully homomorphic encryption or TEs or other things like that to achieve the types of goals that we want, which is that you should be able to have control of your data, but then also opt in and get rewarded for it. We want to be able to contribute to a whole and then benefit from the whole. Because again, I think that this is the big unlock, this edge intelligence that we've got.
Yeah, exactly. Maybe diving into the data, because I think that is a very important question. And I mean, Stability indeed open sourced a bunch of data sets, which then became like, which, I mean, for example, for Lion, right, you could just download images from the URLs. How do you see kind of this conflict right now around, hey, this is public data, this is like copyrighted data, but it's public. This is copyrighted data, but on the platform that you write off all your permissions to, right? Like Facebook, Instagram.
Yeah.
Did they train on public data, which is public to them, and etc. Like, kind of, I'm curious how you see that space because, and I'll yeah, I guess like after that we can talk about synthetic data and how to evaluate synthetic data for the same things like slippery agents, etc.
So, it's very fascinating. Like, I say this as someone who's been sued for $1.6 trillion by Getty and that's company because they were like, use Getty images. We didn't use Getty image data, but this is a big topic because the previous norms of, you have robots.txt and then you can't scrape are now being challenged. And one of the really interesting thought experiments I like to say is this. We're going to have robots, right? 5, 10 years, there'll be like 100 million, a billion robots. They'll be walking around. Are they going to cover their eyes every time they see a Coca-Cola sign or their ears when they've got Katy Perry? Well, probably not, right? That'd be stupid. Like, again, there's this public consumption of stuff. And then there's the whole questions around training, but we're already seeing regulatory arbitrage. So, for example, Japanese and Singaporean law is very permissive there, whereas other countries are much less permissive. Most of them don't even know what to do because this is a complicated topic. From my point of view, I was like, there's a commons, and it's okay to fund research and build open data on anything that's publicly available. We opt out all the robots.txt. Then we opted out anyone that wanted opt out. So we had 1 billion images opted out of Stable Diffusion 3 from the spawning / have I been owned, pwned, trained kind of team gave us that data. And I think that ultimately what we need to get to, though, is no scrapes at all, because scrapes are stupid. Like, what are we really trying to build? Like, it'd be like we take our kids and we let them watch YouTube all day, and then we put them into the workforce. No wonder our models come out slightly insane, right? Like, And that was again the reason for Schelling. It was like, I want to create high quality data sets for every nation, culture, topic, subject area. So you don't need to use scrapes anymore. And then the actual amount of data you need, I think, will be lower because right now it's like we take crap quality stakes and we use giant compute to tenderize it.
Yeah, to
Like
get out the information that you need. Yeah.
you get out the information, but then I was having this discussion with Yoshua Bengio and a bunch of others. Like, what's trained on biological weapon data? Don't teach it biological weapon data. Let's have it on the input versus the output side, right? The downstream versus upstream things. I think eventually we're going to move to a point where any AI that's used for decision making, that's important, will need to have ingredients just like the food that you eat. You are what you eat. And again, I think that we need to, as a society, move away from these big data scrapes to that. But in the meantime, the law can't keep up in time. So we see things like Meta made an announcement. Llama 3.1 is the last Llama model that will be available in Europe. Llama 4 will not be downloadable in Europe. It will not be usable in Europe. Like you can download it via VPN or whatever, right? Because according to European Union law, Meta is not allowed to train on Instagram posts.
Yeah.
Yeah, you had the same thing at Google where Google couldn't use YouTube data and other data for the longest time because of certain other weird kind of things. And so that's just an absolutely fascinating kind of view because I'm just like, okay, fine, don't have intelligence, Europeans.
Yeah. I mean, it's an interesting question because, yeah, like GDPR says you should be able to remove all the data from anywhere it's used. And so if the model saw the data that was then requested to GDPR, you need to go and modify the model to unsee it. How's it going to work, right? Mm-hmm. But your example of like a robot, needs to close its eyes or like have a bunch of filters pretty much on the things it's seen is a good example. I mean, from my perspective, I think, yeah, we'll just see the copyright needs to completely be revised because indeed we're in the world of generative information versus published information. And so that in itself changes how things are attributed.
Well, I mean, this transformation thing, like if you've got a lot of the copyright law is actually at the point of download, but then if I tokenize a data set and I download a tokenized data set, so if I tokenize it somewhere that's regulatory compliant, and then I download and use it for somewhere that you can't download the tokenized data set is transformation literally in code, right? Of the original. So you can have people doing these weird regulatory arbitrage things unless you kind of come to some solution. But the reality is that unless you're someone like we were at Stability, where we're trying to do things right, people just don't talk about their data sets anymore.
Yeah, I mean, nobody even just tries to like open source them. Yeah, they're just like, here's parameters, deal with it.
So when we were doing like image generation, people were like, why aren't you good as XYZ? And I was like, because they downloaded 10,000 movie torrents and trained on that, like ultimately people will just do it because there's no way to trace it back necessarily, particularly for proprietary models. And this becomes very interesting from a geopolitical perspective because China doesn't give a damn about IP and copyright. And so
but they actually care a lot about what goes into the model.
They do. So for the media models, it was interesting because the media models coming out of China now train on everything, Hollywood, everything. Because you think they're going to win, Disney going to go and sue a Chinese company? No,
Yeah.
But they care about it for language models, which is very different. But again, if you're a Chinese company or others, you'll be able to use all of Sci-Hub, for example, right? And these other high quality data sets. Whereas, again, it's getting very, very, very strange, very, very, very quickly.
Yeah. So maybe that's a good segue into, and we talked about that 400B can be a good source of synthetic data. Do you see, actually, I think Jacob Putty tweeted about it, which is like, hey, we see consistent improvement of like smaller models over time being more and more intelligent. And that's because we started, just by throwing random data at them. And now like we slowly reorganizing data with this bigger models that are more intelligent right now. We can reorganize information in such a way that they actually generate the synthetic data to train smaller models. And so I think that the interesting question is, will there be a step change there where as you create these data sets, right, and what you said as well, the like I mean right now it's used for mostly for distillation, right, but you and some fine tuning, but given you can have this larger models kind of running for a while and creating synthetic data sets that are not anymore predict the next token problem, but actually maybe a little bit more sophisticated training setup, and then training on that will actually just be better, and it removes a lot of, I mean, it leaves a lot of questions because like those models were trained on all of this data, but at least now you have all of the training data. It's synthetically generated. It potentially can be open source because it is fully transformed data, and now everybody can go and investigate what are the challenges with that data and potentially fix them.
Yeah, I mean, like I think this is a big like shift now with this model coming out. So now you have DeepSeek and Llama as fully synthetic data reliable at GPT-4 plus levels, 4.0 levels, right? Um, so Microsoft had their paper, textbooks are all you need, that led to the
Yeah.
5 series of models that are entirely synthetic. But actually, the interesting thing is that the 5 models are not entirely synthetic. They're majority synthetic, and then they inject a bit of web data at the end for the generalization. So it's mostly synthetic, and the mixture of those two outperforms. Because right now, when we talk about high quality data, we're not sure what we actually mean. Like, is New York Times high quality? When we did the original stable LM model, like stable LM eventually got to Mistral level before we left, but the first one was one of the worst language models ever released. We broke the scaling law because of Reddit data. And we didn't think it'd be that bad, but it was bad, you know? What is the type of data that goes into these models that optimizes it? There's a huge amount of work still to be done there, where you can do these dynamic ablation studies. Again, this is where DeepIn could be very fascinating, right? Like just putting it on 100,000 GPUs and saying, optimize for this. So we had a paper from our RL lab, Carper AI, called QDAVE, Quality and Diversity Through AI Feedback. It's actually about the quality of the data. It's about the diversity of the data. Taking a Wikipedia article, looking at it from 100 different ways. Taking a piece of code and having various abstractions on top of that code, and then rewriting the code to see how it kind of runs and having, again, feedback functions. And this is where I think you're going to see an explosion in synthetic data, understanding, research, and more to figure out, just like a mama bird feeding a baby bird, the big models feeding the little models, which types of data, because mentally I look at these and like I said, it's like we use this pressure cooker sous vide to take large amounts of crap and we squeeze out a bit of gold, right? But the internals of these models are a mess. And we see this with things like models have multiple layers. We can literally remove entire layers of the model and they still perform the same. It's like, what? It makes no sense, right? It teaches you that the models actually, even though they're dense, have a lot of craft in them. And so when you look at things like the rectified flow work on the Stable Diffusion 3 paper, it's actually very elegant the way that the internal structure of Stable Diffusion 3 was kind of set up. I think it just won one of the best papers at ICML. I'm very proud of that team. What's the internal structure of these models and what's the optimized end form of that versus where they are now? My take is that we probably don't need more unique data than you or I have seen through to university to have an amazing high quality model. The trillions of tokens we use right now are the intermediate step, but again, moving synthetic and understanding synthetic, the ingredients and how to pull them together will be the next big unlock towards these smaller models that are hyper specialized. Because if you have a medical model, does it need to know about civil engineering? Probably not, right? If you've got a coding model, does it need to know about Kafka? With some of the code bases, yes, but
well, yeah, I mean, modern education says you must know about Kafka, right, to be a human being.
Yeah, well, like I said, Kafka-esque code bases, we've all seen a lot. So I think that, again, this is where the deep side becomes very interesting, the user-owned data side becomes very interesting, because the big supercomputers took crap data and compressed it to good. Now we have models that can take data and improve it and look at it from various different perspectives with long context that work on the edge. So we can access the exaflops of compute that we've got there for dynamic model optimization through LoRa's. You look at the work of people like Answer AI and others, getting it working on just individual chips or exo labs or just kind of in here with chaining together multiple MacBooks. There's a lot of compute we can use to build high quality data sets for generalized everyone. And of course, once you've got a high quality data set once, like the pile was very high quality for language, now you've got data comp being much better. We funded that one. You don't need to repeat it over and over again, just like you don't need to redo a syllabus. And so that's where it becomes very, very, very interesting, I think, because that will lead to this next order of magnitude or two more optimization in these models.
Yeah. Yeah, I mean, both having, as you mentioned in the beginning, some mixture of agents, which underneath use a more specialized models. And those models are fine-tuned or even trained from distilled / synthetically generated specialized data sets specifically for problems that they will be solving. Like that kind of pipeline potentially can be a lot more optimal per token, per unit of compute, kind of getting out intelligence, and then being able to route to the right places.
But I think there's probably two more things here. One of which is continuous pre-training of these models, or fine-tuning as it learns about your preferences. And you've got like the LoRa on top of the base model or the series of those. And the other thing is the long context window work that's happening now, with Google using likely ring attention or something like that, now scaled to millions of tokens. Like Llama 3 out of the box is 128,000 tokens, so 100,000 words of input prompt.
Yeah.
And now that we have the state space models and things like Samba that are combining these, we have almost linear scaling, which is insane, And so when we kind of look at that, some of the KV cache work on persisting prompts, etc., like you can combine these in really interesting ways because then you'll have a constantly updating base model and the ability to expand out context length in a predictable way. So you can take the base LoRa, move it to the cloud maybe, and then use cloud compute for giant context window stuff to look at a whole bunch of different data, but with your personalized knowledge. Design patterns like that become super interesting.
So do you see some kind of combination of local generation, but offloading long context onto a cloud?
Yes, that's an example of modality, right? Because if, again, I'd be happy to spend $100 on an inference for a long context 400 billion parameter model. Mm-hmm. But, having the ability to import my local LoRa to that, to look at my entire code base in one, give me a report and send it back, And so this is why, I think I have a task to do, and then your agent will figure out the budgeting of compute of that task. Can I do it with my existing things, or do I need to go and provision something else and access that? And that's why I thought, with Schelling, if we can standardize that for all the open stuff, fully open, that'll make life easier, And then you'll still have Llama and a few of these other things around that. Because you want to have things that are relatively deterministic. Utilizing large context window and function shaping and other things like that, you can have a high level of determinism in outputs versus short prompts with high temperature and language models, it'll just say different things all the time.
Yeah, right?
And that's just like a graduate though, right? The more instructions you give a graduate, the better.
Until you don't explain them what is the tools available to them, right? Then it's gonna run around. Yeah. So do you think we're gonna get to a postgraduate level?
Oh, I mean, we're already there, right? It's just that they're not as depressed as postgrads yet. That's a key concern.
Yeah.
I mean, again, it feels that you're only just the start of this. At Stability, we built a system called Comfy UI for images, whereby rather than having a prompt, it takes every hyperparameter and model and then embeds that entire chain of node logic in the end image. So if I shared that with you, it reconstructed the entire flow. Because I was like, base models and control of models and composition of models. We're still really at a compositional stage in LLMs and language and knowledge, whereas knowledge should be dynamic, structured trees almost. They get adjusted based on your priors, your axioms, and others. And again, those design patterns haven't emerged yet because we're only 2 years into this. Literally, we're 2 years into this explosion. Again, you figured this out way before, obviously, but that pickup,
Yeah, it took a while to scale it to a level where
yeah,
it started to be intelligent.
yeah.
Um, yeah, yeah. I'm actually. I mean, my question been kind of as I was looking at a lot of like some of the recent research is that I haven't seen anyone thinking more how to build better representations and how to train them more effectively, right? Because I mean, you mentioned like right now the representations are a mess. You can throw away like some of the weights and it's going to be pretty much the same. Uh, at the same time, like even when you fine tune, right, it's actually forgetting some of the things, and you kind of need to like balance it by upsampling, other data to like make sure it doesn't forget it and all this stuff, right? So there's clearly a lack of um, kind of understanding is one, but also just in general, like how do we more effectively optimize uh, this models in general?
Yeah, I mean, to be honest, model training is still, until recently, just been more of an art than a science, right? Like, even because you're always compute constrained when you were doing your ablation studies and things like, even at the largest places, because it's always like, well, a bit more scale is good. So how much do I allocate towards model optimization? And we had MUP and we had things like that, but there's still so much more to do, which is insane. But even now, like the whole of Wikipedia is 26 gigabytes compressed. And the new Llama 8B is, let's say, 8 gigabytes or 4 gigabytes Q4. But it can write most of Wikipedia. Like, we have figured out how to represent knowledge and context incredibly small. The fact it knows anything is amazing. And again, as you said, maybe we move beyond tokens to just direct input. Maybe it needs multimodal tokens or Japan like joint representations to kind of move the next step. But the thing now is that there's all the smartest people are now looking at generative AI, so the talent quality is increasing. The capital is crazy, and there's a real business incentive to get this done now. So I think that we'll hopefully continue to see open advances here, new systems and ways of bringing these models together, and again, a move away from zero shot to really intelligent thinking of what is knowledge, how does it come together, what are the representations and internal structures of these, and how do we chain them together.
Yeah, totally agree. I think that would be a big next step. Although some people believe it's just throw more compute,
Yeah.
maybe put some RL on it, and it's gonna work.
Well, then Google will be the winner, right? Like with the V6s and V7s and the interconnect fabric that they've got between the data centers, you'll be seeing multi-million TPU runs soon. Like it's insane again. But I don't think that'll be the case. I think probably what's going to happen is the compute will. This is the last big take up in compute for performance above the level of the data underlying. And then it will be about optimization combinations, swarming, collective intelligence. But who knows? I don't know. You don't know.
Yeah, I don't know. That's one thing that's like the science is not predictable, right? Like everybody will try something and then we'll see what works and then we're all gonna swarm on that to continue expanding it. So
It's not very scientific, eh? Actually, one of the things that really astonishes me is that, again, like sometimes you just got to do it. Like, who is building open source education and healthcare models? We built the best radiology model with Stanford, Check's Agent, other things. I'm like, nobody. But obviously, we should build that now because it outperforms on all the benchmarks, and we should make it open source so it's available to everyone. Like, we don't need the AI to get better now to have individualized education for every child at $10 per year per kid. You don't need it so that no person with Alzheimer's or dementia doesn't have access to all the knowledge there through retrieval augmentation in their language. How do you deal with your family to what the latest therapies are? And so I think you'll see the class of research artifacts continuing. And again, we'll try to optimize. But the really amazing thing, like I said now, is that the technology is there that we can proliferate real world impact to people, which is something that's super exciting to me.
Yeah, I think that's people kind of in this race forget that we actually have something that's like, if you show anyone 2 years ago that like, hey, we have this, people would be like, holy shit, this is amazing, right? And like now we're like,
Yeah.
hey, it's not really good at this things, like, when is GPT-5 coming, right?
Yeah.
Like everybody's like, yeah, I'm just waiting for GPT-5. It's like, why are you waiting for GPT-5? Like you have the most amazing technology of
It is like I remember Stable Diffusion like 2 or something came out and people were like, oh, I can't do fingers. And I was like, can you draw a finger? Like, no, fingers are hard, right? I think part of this as well is, the flow thing. Like, if I use Super Maven or Claude Sonnet, coding is really fun. That's what I kind of found. Before, it wasn't fun with the previous models. And so I think, again, you get to this level of performance where, okay, we take it for granted, but we can do much more now. Like, I can try different things. Otherwise, they're way down on my list. Create a to-do list for the house that doesn't suck. That's one of the projects that I'm doing now. It's like, and I think that just unlocks a lot of mental capacity and the ability to flow. And then our organizations can improve as well. Like, the one thing I advise every organization to have is just an AI tinkerer that just tries everything and thinks about how can we
how to use
implement
it.
this
Yeah.
to make life better.
Yeah, I think there will be a lot of interesting how organizations will transform. I personally more excited about newer organizations, at least, which are adopting this and becoming more productive than existing like larger enterprises introducing and making themselves, even though they have more data, they presumably should be in a better position. But like the processes and kind of I would say like overlap personal and corporate structure, I would expect that to be challenging.
Well, I think that, organizations make you sad because of the lack of information flow, right? And context. So when we start our organization, again, this is one of the learns about stability. I kept very close to the research team, so nobody left last year, and they were offered ridiculous amounts of money because it was fun and they were enabled and they could do their job very well. And the information flow was pretty good. But then when we scaled the corporate side of things, and this is something that happens again, we started to have OKRs and Jira and other things. The responsibility, agency, and accountability was split. If you kind of look at how organizations go now, these models are context machines and they're few shot learners, right? So again, if we design properly, then every meeting we have now is automatically transcribed and added to our global collective knowledge base. And we've got a chatbot that helps out with everything. Makes life so much easier, right? Like we scaled the research on Discord. And I'm just glad that everyone's had their Adderall through that because it makes you so much more ADHD. Whereas now you can have Discord with memory, right? Like,
Well, Discord in
and
general
people,
is for ADHD, so
I don't think it makes it better. I think it makes it worse. Like Discord with memory. But the thing is, like you said, organizations that are AI first should outcompete organizations that are AI enabled or bringing AI in because the data structures and the organizational structures and bureaucracy will stop them from outcompeting. So I think humans plus AI centaurs will always outperform. But are you AI first as an organization? Are you embracing it? Or are you just, where can we use AI to improve? Because you look at it in a very different way. It's like, are we trying to build agents that are autonomous or are we trying to make people more agentic? Most organizations don't want to increase the agency of their employees,
yeah.
you know? And so that's why organizations that are all about the agency of their employees, I think will outperform.
That's true. That's a good point. And I mean, in general, that's what in Web3 we've been trying to do is how do we make individually and community wise more agency, through decentralization, through empowering to own your own assets and kind of make your own decisions in DAOs. Like it's all
Yeah.
toward that world. And it is, I would say, like there's a pretty big differentiation when you try to even build an organization in Web3. And if you still use the principles of like traditional business building, like you always have this challenge where like the space requires agency. And so if you're trying to build OKRs and hierarchy, etc., you're kind of failing in that.
Well, I mean, there's also this self-sovereign kind of aspect as the contributor kind of thing. And what we're trying to do is build protocols for various things, right? And there was this lack of intelligence within Web3 because when you had a big Schelling point like Bitcoin, people who get around that, they understand it. Even though it's changed from peer-to-peer money to store of value or whatever, there is, again, I know what I need to do. I need to mine it. I need to buy it. I need to proselytize it, etc. When you got down to the DAOs and the governance side, we didn't have anything to check the output. So you had like, let's put 200 million into gaming or something like that, like 4.7,
Not referring to
4.7,
anything specific.
nothing specific. $4.7 billion has gone into crypto X gaming. And I can tell you as a former game investor, they're terrible. It's like, again, this misallocation because we don't have the checks and balances, but now with these context machines, we do. Like if you've got a constitution that everyone agrees to, you still have differing objective functions and local maxima. And so let's face it, governance has been premature for all these things and the decentralization of governance. Solid teams that are building with a defined roadmap will outperform. But then we can now build the tools that enable governance and constitutional checking. I mean, indeed, Anthropic's big advance was constitutional AI, AI that matches these things. And now with the large context windows, we can say, given these decisions, and these are the good ones and others, does this DAO decision make sense for the context of what we want to build? Give an independent view. I think we'll see this for more and more things whereby before you have medical decisions by AI, every medical decision will be checked by AI. Before you have DAO decisions made by AI, and maybe, in Wyoming, you'll have the first fully autonomous AI DAOs,
Yeah.
Yeah. Before that, you will have every DAO decision should be checked by an AI. Every single piece of code and smart contract should be checked by an AI, definitely.
Exactly. Yeah, especially for I was actually testing this out, and even GPT-4 was pretty good at finding vulnerabilities in code. So if you prompt it right and like point it at to review a function.
So this thing, we should have a collective knowledge on all these vulnerabilities, and that can literally fit in one context window, right? If you offered that audit as a service, that would be fantastic. Of course, we should be checking all our code. Because how much money has been lost with these vulnerabilities and tests, But then, of course, we should be checking all our decisions because the context of each individual member comes from so many different places, right? And so many DAOs, we all know they're in some optimal ways.
Yeah, I mean, one of the ideas that people discussing on our governance is creating an AI delegate before indeed AI decision maker. So you can actually have people delegating to it, and then it's voting on behalf of its kind of delegatees. And so the interesting thing is it kind of creates a economic force where if it's making good decisions, more people delegating to it. So over time, it can become, have more and more voice, which I think is an interesting way to experiment and kind of ramp it up.
Yeah, I'd say that's really interesting because there's a optimization equation there. And like I said, the other thing is you have a set of agreed principles around the governance and everything. All that should be uploaded to a large context window model, along with what the community views as being great decisions that have been made, along with local context that's relevant. And it should be asked again and again, like, please look at this from all the different perspectives and scenarios that the community wants. How does this work? I think that technology at the point now will actually give really interesting feedback. This comes down to, citizen assembly type things, whereby if you take groups of citizens and you actually inform them about a topic over a few days and cut them off from the internet, they actually make really interesting informed decisions, And now we have the ability to almost scale that.
Mm-hmm. Yeah. I mean, that's kind of what the government, like US government has all of those agencies that's supposed to like evaluate the budget, the EPA, all of this. They just don't very work efficiently, right? So here
it's because the lack of context shifting and inadequate local maxima, right? Like the whole thing is the sociopaths reach the top, the Gervais principle, like the office. And then because everyone's writing reports all the time and writing reports is hard, like it all becomes about just perpetuating yourself and gathering more and more political power. And that's why you have like a railway line in California of 100 meters or something that cost $10 billion.
Yeah, 5 kilometers. Yeah, in the middle of California. Yeah, it was a test.
But again, like I think this is really fascinating thing right now, where I was like, we can really build the open infrastructure of the future because it said a organization that embraces this technology for healthcare, for education, will outperform those that don't. Like literally
Yeah.
one-to-one personalized education for kids using a Claude Sonnet level model implemented intelligently for a kid in Nigeria will probably lead to that kid outperforming a kid in Detroit or Washington or something like that, you know? Which
Yeah, I
is
agree
just
with
like
that.
amazing, exciting. I think
And
for
it can be
Web3, that's
like
important as well.
personal tutor that knows exactly how you learn. It knows how to present information. So
Are you visual? Are you auditory? You know, have you got dyslexia? And that will all be there. Like we've got the cost on tablets down to $7 per year per kid in Africa now with solar power and Starlink. And so I think that will be a huge unlock. And I think for Web3 as well, 76% of Web3 developers are outside of the US. So this is a blessing and a curse. The curse is that you have again these local maxima and people don't understand each other's context and you get these tribes and everything like that. There's also a lot of potential if we can use this technology to break down the barriers and augment and really get people to agree, why are we building near? Why are we building Schelling? Why are we doing these things, right? I just need a little bit of support.
yeah. Well, I mean, that's why we're doing this, is to educate people and kind of get people to understand why we're doing this and how it all fits together. And it's not just, yet another Web3, yet another hype. There's a lot going on to actually enable and keep it user focused, keep it community focused efforts
Yeah.
with this intelligence tooling.
Yeah, it's super exciting time. And I think, we're at the tipping point now. Again, like it was just really fun using Sonnet, and now Llama 3.1 405B at the same level. It was really fun using Stable Diffusion, I think a lot of people come into Web3 because they want that high degree of agency and control and self-sovereignty. And now if we can get this technology to that group and increase that group, people want agency, they want control, they want to be able to believe they can create. And so let's unlock that for as many people as possible.
I agree. Well, we're coming to the end, so I will wrap this up. Thanks, Emad, for coming. I think it was an amazing conversation. I totally agree that as more of those tools are empowering agency, I think we'll see amazing results across the world. So thanks, and tune in next week for more.
Cheers, everyone.